Hello everyone, D. Alfred Ostrowski. In this recording, I'm going to be presenting a tutorial / demonstration of a DApp using Hardhat React and Solidity, obviously, on Ethereum. I'm going to be demonstrating a voting application, very simplified, and it's a good starting point for any number of applications of which you might want to record some type of voting or survey-based information. I'm going to be starting from scratch. Going to be running everything on the AWS EC2 instance as usual. And also all the instructions and steps I'm going to be going through are well documented on my GitHub. So you can go through and follow through and get up and running in just minutes and run the DApp and see how it's constructed and use it for your own needs. So let's get started. I'm assuming you have an Amazon account as usual, and that you have referenced the EC2 and you have a appropriate client software and a PPK key generated. So let's get started. I'm going to do a launch instance and install my software, start from 0 here. I'm going to use the Ubuntu instance as usual, 2204. And I'm going to run a C5 instance for Hardhat. It's going to give me my personal blockchain. And this has been working well for me. Okay, I have a PPK key generated. So let me do launch instance here. The C5 runs pretty fast, so I'm not really going to have to pause anything for the recording. I'm going to set my security rules so I don't have to worry about that moving forward. I'm going to click into my security group. I'm going to click on the over to the right, which I just did. Going to click all traffic as usual, IP4, save my rules, and I'm going to be good to go. I'm going to go back to instance, and I'm going to look at the details, bring that up because I'm going to need my address and my DNS information. I'm going to set up 2 terminals, one to run my Hardhat and one to support the DApp, right? So I'm going to pull my secure shell PPK key that I've generated. I encourage you to use the same region. It just keeps things simple. I don't use a password because I'm using this primarily as a sandbox, so I'm not overly concerned about security. I'm going to bring up another terminal again to run the application, and then we can start doing the installs. We're going to be up and running pretty fast. Oops. I set a 30-second timer on the connection that keeps me from timing out. And I don't set a password as usual, so I got my 2 screens up and running. I'm going to overlay one over the other, use one to install the software, and then we can split it off and watch the blockchain running in the background. So let me do the install. I'm going to start off with the sudo apt-get update, pretty much standard for installs. It's going to be a lot faster than working with Ganache. I don't have as much software to install. Again, all these are going to be under the README install on the main directory of the GitHub that's associated with this video. I download Node. Now, I don't use sudo install for Node. It's going to give me an older version, so I'm going to bring up a newer version this way. I create a bash script for sudo, and then I'm going to be running it in the following step here, right here, sudo apt install node.js, and I just default that. I default everything on the installs. Okay, I'm not doing any special configurations. Now you'd be running a different platform, but this gives you a good starting point to be up and running. You have a good reference point to modify it to suit whatever your needs may be or platforms. I like Web3 still, okay, for my React work. And I'm really relying on both Ethers and Web3. So for that reason, I've installed Web3 here. If I go 100% Ethers, I'm going to be removing that command from my startup script. This is some of the background software Nomic Labs for the work with Ethereum. As soon as that is complete, it's not going to take long. I'm going to go to my installation, download an installation, and create React app. I'm going to create a project directory called voting. NPX accomplishes both tasks in one command. When this is done, I'm going to CD to the project directory. In the past with Ganesh, I ran it outside. Here, I run it inside. That way I get the configuration is placed directly into the project directory. It may be advantageous, perhaps install it outside and set up in a slightly different fashion. That way you could use it among different projects. But in this case, I'm just doing this as a sandbox. And I'm not going to be using this node for long-term installation. This is going to run fast. It's going to be over in a few seconds here. There we go. So we're up and running. I have a project directory called voting. I'm going to CD to that directory, and I'm going to do an npx hardhat. This is going to do both the download and install of the hardhat. I'm going to be defaulting that. It's going to prompt me for a JavaScript project, and that's why I'm going to choose and default the, I believe it's 3 other options. What do you want to do? Create a JavaScript project, and it prompts me for that project root, home Ubuntu voting. That's exactly what I want. And I default the get, ignore, and crash reports and project dependencies. Now I'm going to have 4 edits. I'm going to be editing the Hardhat config file. I'm going to setting up my smart contract, the deployment script, and finally my DAPP, my React-based application for the voting application here. Hardhat is now set up, directly overlaid in my React project directory, right? So I'm going to do an edit on the Hardhat config file. This is what it defaults me to. I'm going to add a few things, mostly to support the leveraging of an EC2 instance. Okay, so I'm going to define network localhost, and I'm going to explicitly use this to define my DNS to make sure that I can continually update this upon getting a different DNS. Sure, I got the top line. I got that. Great. So let me modify that DNS. I don't want to forget. Then I have to go back and change it, right? So I'm going to grab my old DNS and I'm going to update that. I go to my instances. And cut paste it in there. So let's take a look at what we have. From the top down, I import Hardhat toolbox, do module exports, going to set up an artifacts directory, most importantly under source. It's going to allow my application to read under the source directory. You are constricted in any web-based application of reading all over the server. So I have to relocate the contract information, which under an artifact directory, I'm going to rename it under source, and I can read and write it appropriately. I'm going to define my networks. I'm going to define a local host with that URL defined to the DNS. I'm going to use a default chain ID. And I have default here value, Hardhat value I'm not really relying on, but we could just leave that as further reference for other projects. And the definition of solidity that came with the default installation. So it's one down, 3 to go. Okay, so let's look at the smart contract. So go to contracts directory. I have the lock example, that's default. You can go into the Hardhat documentation, learn more about it and how to use it and get a little more insight on working with smart contracts. In this case, I have my own smart contract, so I'm just going to pull that in, voting.solidity, and let's step through this. Okay, so here I have Pragma Solidity. The hat is going to say any version 080 equal to or greater than, right, that version. Contract voting, my main data structure is an associative array, a hash function. String is my key and pointing to an integer. Okay, this could be any type of information that I'm going to want to record votes for. Okay, it could be a survey, customer survey, it could be an employee survey, it could be a formal voting application, be voting on issues, voting for anything, right? And here I have a list. In this case, I named it as candidates, but this is the list of keys that I've appropriately named, in this case, as candidate list. My constructor is going to read in an initialization array. I don't have to bake it into my smart contract. I build it right in my deployment script, and it could be, again, any number of key values, okay? And that's going to be passed into candidate list appropriately. It's going to be publicly referenced. Next, I have total votes for. This is going to take a key and return the value of which it points to. Okay, I'm going to also check valid candidate. We'll see that further down. That's going to make sure that it's being passed in as a valid key value that matches. It has to match that list. If it doesn't, that's going to drop out. Vote for candidate works in a very similar fashion, except in this case, it's going to update that integer, incrementing it with the plus equal 1, which is the abbreviation of equal value plus 1, right? So, and it's going to call require. That'll drop me out again if I use an inappropriate string, and that is good fodder for doing assertion testing. We'll cover that later on with some more advanced topics. Valid candidate is going to do the string comparison. So Solidity is not very sophisticated, okay, with the support for string functions, as we have in a lot of other languages. Here we're using this existing KCCAK256 function after it's been converted to bytes, and it's going to do the functional equivalent of a string compared to. Next, I have a function that's just going to return that candidate list as it's being initialized, and it's going to give me the value that I could just desk check that to make sure it's being read in appropriately. And I'm done with my contract, good to go. Now let's look at the deployment. I'm going to go under scripts, and we're going to edit that and put in the deployment script, right? So let's go to scripts and just see what the installation gave us. It gave me the deployment on the lock smart contract, and we're not using that, right? So again, it's a good practice to see exactly how it works and work with that. That is actually documented on the Hardhat site. So if you have a chance, I definitely recommend that you take a look at that, and you could use it in comparison to the version that I have here, right? But let's go through what I have here, and this is going to do the deployment for my voting contract. So I start in, I'm going to pull in Hardhat and Web3, just in case I need it. I'm going to use get contract factory. It looks under the contract script. It's going to look for contract name voting, which I just put in, right? I'm going to initialize, in this case, a list of candidates, a list of an array of strings. And it's going to pull that into deploy, and it's going to use a map function with an anonymous function here, iterating through the names and pass it in as a list. Here, I'm going to do a wait on the deployment. and it's going to use the await and wait for that to complete. This is important, right? To use await, because if it's not synced out appropriately, then I may not be able to get an address in this case. I need that address. Okay, so I want to write it all from the deployment script. I want this to happen behind the scenes, and that way you're not going to have to manually cut, paste contract addresses and things like that. Okay, so this is really going to clean up your deployment exercise, right? So I'm going to take that contract address. This used to be an attribute. You have to use a method with this version. So I use get address, and I pass in that contract address, and that is going to pass into save front end files. It's going to create two files. It's going to create a file with the ABI information and a contract information. We'll take a look at it after it's created. It's quite simply going to create it under source contracts data, and this is going to make it accessible from my DAPP application that we're going to look at in a second here. It's going to create that directory for me. I don't have to worry about creating it. It's going to add that to my project directory. It's going to do a write in a JSON-based information using JSON stringify, a single key value in this case with the contract address. And then following that, I'm going to read the artifacts directory and read the entire ABI information. That's my entire smart contract start to finish, represented as JSON-based data. It's really your schema or definition for your smart contract, and it's going to put it in a place that is readily accessible from my application. Then I'm going to execute the deployment, and I am done. Okay. Now the smart contract, or the application, I'm sorry. So I'm going to go to app.js, look at the default. We're going to replace that. You can do a test on it just to make sure React is running, but I'm confident it's going to work for us, right? So, but if you need to break things down, that's always a good starting point to step back to and essentially say, hey, did this work? Let's go out and try, go take a step back and just try the base create React app to make sure it works. Okay. Here I have one more edit. I have to edit my DNS. Okay, most unfortunately, if I can find a clever way of doing it, I'll do it. But for now, with EC2, you have to pull in that DNS. It's going to lose its mind because it's not going to know where to pull in the information from localhost, right? So now I have that in here. So make sure I did the save, and I'm going to step through line by line and read this through, and then we can run it, see how it works, right? So first things first, I import React component from React and Web3. Pretty standard boilerplate React.js code. Here I'm going to import the ABI information from voting JSON and the contract address. We'll take a look at that after we do the deployment, which hasn't been accomplished yet. I'm going to extend component, and that's going to support component will mount, and I can call a function to load that blockchain data in. That's going to run behind the scenes. Before anything else gets started, it's going to connect to my data source. In this case, it's not a database. It's my personal blockchain running on Hardhat. I'm going to validate the address ABI information that it was read and appropriately from the imports. I'm going to write it to the console. You can see that up and running. Again, I like to rely on Web3, this case, instead of ethers. And I reference my DNS appropriately, 8545 standard port. I'm not relying on a wallet in this case. I'm just going to simplify it. I'm going to have later content where I'm going to talk about wallet integration. Let's get it up and running. And I find your troubleshooting, your smart contract, and your React application using the wallet kind of puts in a couple extra steps of pulling the appropriate information. It's nice to do it this way and then later on add that, okay, when you want to establish it more as a production application. So here I do a Web3 ETH get accounts, and I assign an account to my main state variables using that hook set state. I'm going to take that first account indexed to 0 and assign that as the value to account. Next, I instantiate the contract again using Web3. I use my contract definition ABI, and I take the address and I'm going to assign it to contract options address. And I set it the state for the contract that'll make it accessible by the other method that I use for the voting. Next, I pull in that contract list and use that get candidate list. And that's just quite simply to validate that information. So I can see that I have the confidence, I have all my data that's being read in. It's a nice means of troubleshooting in case you do have some kind of problems. It can allow you to identify any type of defect before it happens, right? Here I pull in the votes for the two key values, and you could set up as loop and iterate through the list. In this case, I just hard coded it and set it up appropriately, right? And I set the state, and that'll be read from the interface. In constructors, I initialize the state. Most importantly, I have a voting method. I need to bind this to this voting using the current value this. That gives me my current reference to the existing object, okay? Next, I have the definition of the voting. This calls vote for candidate and the total of the votes. So I'm going to vote for a given candidate, and I'm going to update that vote appropriately. I pass in some gas in the account. In lieu of having the wallet operation, I just do it all through the send operation. And then I do a call console log to pull that data out and update the UI as I proceed. So I'm reading and writing reading and then writing and then reading from the contract and updating the UI. So here's all my UI, 2 buttons and 2 states that are going to be defined in the user interface. And I reference this voting and just use a simple click and pass in the associated value. So I got my DNS set up the security. Let's do start up the blockchain, see if that works. And then we can do the deployment starter contract. So here, again, we need to be running it directly out of the project directory. And again, all my commands, they are set up appropriately. And let's grab my DNS, make sure I have the right one. I'm going to stage this off screen here a little bit. We're going to pull it and take a look at it. So again, I need to make sure now, if you recall, I installed Hardhat in the project directory, and that is exactly where I need to be running it, right? So I need to be under voting. If I do out of voting, it's going to try to install Hardhat. Okay, so here it's going to identify with the node, npx Hardhat node, and I have to identify my host name appropriately, 101, and I believe I have the right DNS. Okay, so let's see if it works. Sorry, let's start it up. It looks good. Okay, let's take a look at it, scroll it up. I got my 20 accounts. They all have 10,000 ETH. And it gave me the green signal, started HTTP WebSocket, add associated server. Looks good, looks good. I'm going to leave this on the upper left so we can watch that run as we do our deployment. I'm going to back on a source. I'm going to do the deployment directly again from the project directory. If you recall, from the configuration script, I define localhost with the DNS, right? So here I'm going to do the deployment, complain a little bit, but if you see in the background, it did do the deployment of my contract, use some gas, and it gave me that contract number. Now, most importantly, let's go to source and show you what the deployment script did for me. So I have the contracts data, and it copied in a voting JSON, and not only did it copy and it created the directory, then copied it in, right? And if I do a cat on voting address, there's my address, and that address AA3 that matches the contract address that's being assigned. And then I can just do a check on the JSON data, and I have all my ABI information. So this, most importantly, is placed in a source directory that can be read by my React application, right? So we got problems, you don't know if the deployment's working or something worked. This is a good stepping point to go through and have that confirmation that things, because things are going to break, right? It's one thing or another is going to happen, right? So I have my DNS set in the application. I think I'm good to go. We do an npm start, and finally we can see if this application is going to work appropriately. So the Babel library is complaining, but it's not giving me an error. So I get a successful compile, and it looks like it's running at port 3000. So I'm gonna grab my DNS, and I could just do a separate tab, and I can test it right here. Here's my application. Let me bring up the developers console. We can take a look at what's happened so far. Okay, and this is why I put in those console logs. Okay, so I have the address, the AA3 that showed up, right? ABI, all my ABI information. I can see all of my definitions. Okay, so it's looking really good. Look at the candidate list. I can click on that, and I have the 2 keys. So all my data is being read in already with that behind the scenes component. So let's run the contract. And it's also nice to look at here. It did some calls to contract here. I can split my screen a little bit, and you can see it running in the background here, right? So I'm gonna do a vote, and you can see it updating in the background, 2, 3, and it's updating as it exists. If I didn't define it as async, okay, then I might have some problems. I have to refresh the screen to see it update. It's updating on the fly, and I can update as well here. So I have 3 and 3. Let's go one more, and I can even kill my application. Okay, so that is, sorry, it's this one right here. So that wasn't an inactive screen. There we go. So I completely stopped my DAPP application. I can start it up again. And let's see it load in. I should have, I believe, 4 and 3, if I'm not mistaken, right? So I could, and just to make sure I'm not caching or anything like that, I can actually put it in a different tab, right? And run it as such. And so let's see if it comes up appropriately. So I have 4 and 3. Okay, and did another call and updated it, and I can keep on going. And it's working appropriately. So there you go. So what do? Started from 0. We installed Hardhat React, associated libraries, pulled in 4 files, Hardhat configuration, smart contract, and the modified deployment script. Most importantly, that's going to take that contract information, put it under source, and then my app.js, my complete DAPP application. We ran it, we saw it work, looked at some of the diagnostics, and everything worked appropriately. So again, all this information is going to be under the GitHub. And thanks for listening. Hope this helps. Talk to you soon. Thank you.